When people talk about healthcare and AI, they often think about fancy applications like building an AI doctor that's going to do medical diagnosis for patients. But in reality, the more practical question nowadays is how we can use AI to automate healthcare administrative tasks. This is $1 billion question. So one such task is called medical coding. Medical coding is basically the conversions of unstructured clinical notes and reports into some standardized coding. And this standardized coding is actually used for many different tasks in healthcare, like insurance claiming and medical research and data analysis, etc. So today, we're going to build an AI agent system that is going to automate medical coding for us. During a medical consultation, a doctor will spend a lot of time on writing clinical notes or reports. But you can see how it is a problem when, let's say, you have to file for an insurance claim. Since different doctors would have different ways of describing a condition, and let's say different clinics and hospitals, they have different ways of managing their data, you will see how it will become a headache when insurance companies have to determine whether you actually have a condition or not. So therefore, in a healthcare system, we heavily rely on medical code, which basically is a standardized code to describe whether you have been diagnosed with a condition or whether you have went through a particular procedures or treatment. So let's say if the insurance company see that I have a medical ICD-9 code of 820, the company would know that I was diagnosed with hip fracture. But then you would imagine like such a task would rely on some human to do. So in some countries, there's actually a job called medical coder, where basically that person would do medical coding all day. So let's say in Scotland, on average, a medical coder would spend around 7 to 8 minutes per case, which is about 60 cases per day. And in some countries where this job doesn't exist, this burden will fall into doctors. So doctors, they have to do this administrative task of medical coding. And you can see that the more time the doctor spends on these kind of admin tasks, less time on treating real patients. When we have an expensive problem we couldn't solve nowadays, we try to use AI. I'm a medical data scientist, and during my PhD, I actually attempted to solve this problem on the side, but I failed. During that time, I treated this as a supervised learning problem. Basically, what that means is I took all the clinical notes I have, and then I tried to predict what's the best medical code we should assign to a patient. But such supervised learning techniques actually have many limitations. For example, it is a black box. So let's say my model says this patient, the optimal medical code should be 820, which is hip fracture. I couldn't ask why. I couldn't see the reasoning behind this prediction. Also, such model usually breaks when I move on to another condition. Let's say if I apply my model today on a medical coding task of diabetes tomorrow, basically this model wouldn't work well anymore. And let's say if I move this model to a different hospital or even different countries, again, the models usually breaks. So this is where LLM comes in. So large language model is the model behind Gemini and ChatGPT. And the design of such models is actually aligned with medical coding tasks a lot, because it's basically a task of trying to make sense of large amounts of data and try to produce some outputs. So in the large language model design, we could actually stop treating it as a simple classification problem, but more of a reasoning problem. We could actually mimic the reasoning process of a human medical coder and also even integrate medical guidelines to the system. And the best part is we could tell the system to show us the reasoning behind why this patient is assigned to a particular medical code. So now let's try to build this system together. The demo today is based on this study here conducted by a healthcare AI company called Corti. Disclaimer, I'm not connected with this company and they didn't pay me to do this. I just find the idea interesting and just want to share with you guys. So basically, the team here at Corti has developed a medical coding AI system. And the most interesting part of the study is this figure 1 here. Basically, what they did is they built 4 different AI agents and then connect them together so that they could convert some free text clinical notes as input and then convert them into some standardized medical code. Basically, they have 4 different agents assigned with different tasks, and the first agent here, agent 1, the evidence extractor, could take all the free text notes and then extract the key evidence from the notes. Basically, those are sentences and keywords that could be used to be converted into medical code. And then in the middle, we have the index navigators and the tabular validator. Basically, those are some processing agents which could do the searching and then verifications of the medical code. And finally, we have the code reconciler, which basically is like a final checking agent that could look for any medical codes that could be like contradict with each other and then remove the redundant code so that we have a final list of medical codes that we could use. So this is the entire like general workflow of this system. Of course, this is a study conducted by a company, so they wouldn't be able to just let us use the model they train directly. But what we can do here, we can take the idea of the workflow and then we can implement our own system using some open source AI models. So this is what we are going to do next. If you do not want to build a medical coding program from scratch, our team has actually prepared a mini program for you guys to try it out so that you can experience how this workflow is like. If you want to set up this program, just go to the link in the description and there will be further instructions on how to set it up. So once you opened our medical coder program, there's one thing we have to set it up first. That is tell the program which AI models we want to use. Because this is essentially a large language model based system, we are using some LLM to process the clinical notes and then generate some outputs. So we have to tell the program where to find these models. Of course, if you want, you can use third-party solutions like from OpenAI or from like Google, but you might not want to do it because you do not want to pass your personal information or the data from your patients to like a big corporate. So often in the context of healthcare or any like high-stake industries, we would like to use like offline models. But if you want to use offline AI models, you also need to set up something called the LLM Studio. It's a program helping us to manage local AI models. If you want to know the details on how to do it, you can check out my previous video on offline AI models. But once you have LLM Studio set up, you can go to the left-hand side here, and you will see on the second icon here, there's a tab called Developer. What we have to do here, we have to switch this button, this Start Server button here, and make it green. So that basically means we have set up a local server so that our external program, including our medical coder program, could access the models within LLM Studio. And another thing we have to be aware of is this URL here. This is like an address. So we have to copy that and then go back to our medical coder program and then paste it under the base URL section here. Basically, after we have done that, our program will know where to find the models. And another thing we have to do is we have to choose a model. In LLM Studio, if you go to the model search section here, there's really a whole bunch of models we can choose from. And then we have to tell our medical coder program which model we want to use. So if you go to the My Models section here on the left here, you will see all the AI models I've downloaded and installed in my machine. And for this demo, I only have one model installed, which is the JAMA 3.1b model. It's a tiny model. But what we want to do is we want to copy the model name here, JAMA 3.1b, and then paste it in the model name section here. And once we have that set up, we can click Save, and then all the settings will be ready. So after that, we can start feeding some clinical notes into our program and see what happens. So I've actually provided some simulated clinical notes. And what we can do, we can scroll down there and just click Generate Code. And now you can see all the results here. Basically, these are all the diagnosis codes that have been identified. and also some procedure code matching this particular clinical note. And you can see the beautiful thing here we have the pipeline thought process map out. So just now, as I mentioned, there are like 4 different AI agents involved in this workflow, and the thought process of all of these agents could be represented here so that we can actually know why the models have decided to pick a particular code as the final answer. If we look at the result in more detail, it's actually not that great. First, if we look at diagnosis code, we can see that 2 medical codes related to type 2 diabetes were selected, so that's a good start. But the thing is, it doesn't make sense to put both together. The first one here is a more vague description of the condition, whereas the second one is a more specific version. So if I'm a human medical coder, when I look at the doctor's note, I either are not too sure about what the doctors mean, then I will pick this first big version, or I'm confident that it's a specific one, then I will pick the second version. But then it doesn't make sense to have both. I think this shows how the AI agent isn't doing a great job in resolving the contradictions between the different medical code. Another problem we have is the procedure code. You can see that our system has identified pacemaker as a procedure. But if we look at the original clinical notes, the doctor has mentioned nothing about doing a pacemaker procedure. So this is entirely a mistake. This actually shows the importance of having human in the loop when we are trying to build some AI application in high-stake environment, like in a clinical environment. Because if we just take the AI-generated results directly and integrate it into our workflow, it would be highly dangerous. So we need some human professionals with medical knowledge to help do the review of the result. So some people might ask, okay, this is terrible. The results, there are many mistakes in the result. So what's the point of building such a system? Remember one thing, when I did the demo, it's just based on a simple, small large language models that I picked from LLM Studio. This model wasn't specifically trained to manage medical tasks. So if we pick a bigger or a more specific trained models, the result could greatly improve. So if you guys are interested about model selection, feel free to leave a comment, and if there's enough interest, I will do a new video about model selections on medical coding. People are often tempted in building fancy AI applications like an AI doctor, AI lawyer, or AI trader. But often the real money and value lies in building AI system that is going to automate some tedious, boring, but expensive task. This is particularly true in high-stake industry like healthcare or banking, where some manual, inefficient workflow has been around forever. So moving forward, we are going to build more project-driven videos like this one. If you like my content, please subscribe. I will see you next time.